All right, how you doing, geometry students? Just thought I'd post a little video, maybe to review some things about proofs and use properties of parallelograms and sufficient conditions of parallelograms a little bit differently than we've been doing with congruent triangles. So if you get onto Edmodo and see this, spread the word, let people know it's here. Remember, because of the snow day, we're going to just go over the quiz together in class and use it kind of as a practice tool, and the test will still be on Friday, but we won't be having a quiz per se. And don't forget that I have a study session after school on Wednesday, tomorrow, so if you're able to take advantage of that, that'd be great too. Alright, so here's a couple proofs, and in this case, a little bit differently than we've been starting. We're starting already with the triangles congruent, and we want to prove that this thing is a parallelogram. And so now we have a lot of ways that we can go about proving something is a parallelogram because of all the sufficient conditions. So we can look at parallel sides, but in this case, this is where it's leading us. So here, since this first step is given for us, we want to find that angle. So SQ and then our PQ. And those are parts of the triangle up here that we already know are congruent, so we can use CPCF to say that those are congruent. And so that's a little bit different angle than we've taken before. And then how does that help us get to parallel sides? Okay, so we want to prove it's a parallelogram, we need some parallel sides. And so we can draw our little Z on here. Oh boy, terrible. But there's our Z theorem, and that tells us then that side SQ has to be parallel to PR, because those are alternate interior angles. And so in this case, we're starting with the angles congruent, and we're concluding that the lines are parallel. And then we want to do a similar thing with the other sides. We want to use alternate interior angles again, and this time S, P, Q, and R, Q, P. And so now, let's see if I can draw this Z a little better. There we go. So there's our Z. And this time we're using sides SP and saying it's parallel to QR. Okay, the angle, once again, we came up with for that same CPCF reason, because it was already a part of the triangle that we were given is congruent. And then we have another AIA step. So this proof is really about using the definition of parallelogram, coming up with two sets of parallel sides. And so why do we know this thing is a parallelogram? Because of definition. Okay, the next one is going to take a little bit different angle. So we can have the definition, or we can start with it being a parallelogram and use the properties that we know about parallelograms. So sections, those last two sections we did, really what are all the things we know now about parallelograms. And so if this thing, we're switching this, the given is that it's a parallelogram, okay, and we're going to prove the triangles are congruent this time. So if I know this thing is a parallelogram, I know both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, and that the diagonals bisect each other, but here the diagonals really aren't drawn on there. So let's look at how we're kind of being guided to start, is that those two sides have to be equal. And so if this thing is a parallelogram, the opposite sides have to be parallel, and that's a property. We know it's a parallelogram, so we can use the property of parallelogram theorem to say that. And similarly, SP is opposite RQ, and so by the same reason, we already know it's a parallelogram, so by properties of parallelograms, we have these opposite sides have to be congruent. And then if we want to get to being a triangle, our triangle congruence theorems always need 3 parts, so we need one more part, and there are a number of ways you could go about that, so maybe take a look and strategize what you think you might do next. But we could keep going with the properties. One of the properties is that angle S would have to be congruent to angle R. Those are opposite angles in the parallelogram, so we could have one more step using the properties of parallelograms. Or the other one, remember, is that anytime there's a shared part, so I kind of want to emphasize this because I want to remind you that you can do this, look for wherever it's attached, so these two triangles are attached right down the middle here, and they share a side, and that's always the reflexive property. And then once you have your 3 parts, use a triangle congruence theorem to talk about why you know those triangles have to be congruent. So in this case, I did side, side, side. If we went ahead and did angle S and angle R, and then we got rid of this, now what triangle congruence theorem would we have? We have 2 sides and an angle, and so the question is that angle between? And it is, so it's side, angle, side, right? Side connected to the angle, connected to the side, all connected to one another. And then the last thing I wanted to remind you about is hypotenuse leg and big side, little side angles. So remember that in a right triangle, okay, HL is one of your triangle congruence theorems. And so the H stands for hypotenuse. And so if you know that kind of information on the triangle, all right, it's not side, angle, side, because the side is across from the angle, and in this case it's a right triangle, so HL would be our justification. If we had this similar looking triangle, but we had this kind of information, we didn't know the right angle this time, or maybe it isn't actually a right angle. In this case we have side, angle, side, so just be careful that just because it might look like a right triangle or whatever, it's not necessarily always going to be HL. And then a similar looking triangle, but marked a little bit differently. And in this case, 2 sides. So all of these examples, we have 2 sides and 1 angle, but you have 3 different justifications. And so this one, 2 sides and an angle, but remember that you want to look across from the angle that's marked, and the justification that would go with it would be big side, little side, angle. And so the question you have to ask yourself is the longer side across from the angle? Oops. Angle, you know what I'm trying to say. Okay, and in this case, is this side right here longer than the other side that's marked? And it's not. Alright, so this would be one that you'd want to explain why big side, little side angle does not apply to that triangle. because it's not the longer side that's across from the angle. So 3 different triangles marked with 2 sides and 1 angle, but 3 different ways to go about it. And then the big side, little side, okay, it's got to be arranged correctly, the things that are marked on there, for you to be able to guarantee that it's going to be congruent triangles. All right, have a great day.